Picture this, the sixth planet from the Sun, a gas giant 95 times more massive than Earth, could actually float in a bathtub if that bathtub were big enough. No, seriously, I'm talking about Saturn, and this mind-blowing fact reveals something incredible about the architecture of our solar system. To understand why this is possible, we need to talk about density. Density is simply how much stuff is packed into a given space. Think of a rock versus a feather. The rock has higher density because it packs more mass into the same volume. Now, here's the crazy part. Saturn's average density is about 0.687 grams per cubic centimeter. That might not mean much until you realize that water's density is exactly 1 gram per cubic centimeter. Yes, you heard that right, Saturn is less dense than water. This means if you could somehow create an ocean large enough to hold Saturn, it would actually float, with about 30% of its mass bobbing above the surface. Now you might be thinking, but wait, Saturn is huge, it's the second largest planet in our solar system. Exactly right, and that's where the real magic happens. Saturn is what we call a gas giant, composed mostly of hydrogen and helium, the same lightweight elements that make balloons float. Unlike rocky planets like Earth that have dense cores and solid surfaces, Saturn is essentially a giant ball of gas with a relatively small, dense core at its center. Imagine Saturn as the cosmic equivalent of a marshmallow, enormous in size but incredibly light for its volume. To put this in perspective, Earth has a density of about 5.5 grams per cubic centimeter, nearly 10 times denser than Saturn. That's why Earth would sink like a stone in our hypothetical cosmic ocean, while Saturn would happily float. Now, let's visualize this floating scenario because it's absolutely wild to picture. If we could magically transport Saturn to some unimaginably large body of water, you'd see this magnificent ringed planet just gently bobbing on the surface. The iconic rings would extend far above and below the waterline, creating a breathtaking sight. Of course, this is purely theoretical since no such ocean exists, and Saturn's gaseous nature means it would dissipate and mix with any actual liquid water. But the principle stands, Saturn's composition makes it buoyant in water. What's truly fascinating is what this tells us about planetary formation. Saturn formed far from the Sun, where temperatures were cold enough for hydrogen and helium to accumulate in massive quantities. The planet's rapid rotation, a day on Saturn is only about 10.7 hours, causes it to bulge at the equator, further reducing its average density. Scientists believe Saturn might have a dense core about 15 to 18 times Earth's mass, but this is surrounded by such enormous volumes of low-density gases that the overall average remains below water's density. This floating fact isn't just a cool party trick. It's a fundamental property that helps astronomers understand how different types of planets form and evolve throughout the universe. Every time you look up at Saturn in the night sky, remember that you're seeing a world that defies our earthly expectations of what a planet should be. It's a gentle giant, light enough to float, yet massive enough to influence the orbits of other celestial bodies. This paradox of size versus density makes Saturn one of the most intriguing objects in our solar system. The next time someone tells you heavy things sink and light things float, you can blow their mind with the Saturn exception, proving that in the cosmos, the rules are often more amazing than we imagine. What other planetary facts blow your mind? Drop your favorite space trivia in the comments below and follow for more cosmic revelations.